Okay, geometry fans, our topic for today is Unit 3-2, Parallel Lines and Transversals. Before we start, let me give you your joke. What do you call an alligator in a vest? And the answer is an investigator. Okay, so a lot of today is going to be vocabulary, and what we're going to start off with is a word called transversal. When you see the word transversal, that's a line that intersects two or more lines, a line that intersects two or more lines but not in the same place. Trans means across, and VERS, verse, is actually a line, so across a line. Now it doesn't have to be with parallel lines that this happens, but typically we'll be looking at a situation where you have one line that's crossing two other lines, or two parallel lines will be the most common situation. T is the transversal, so that's this line, and it's crossing A and B. And what you realize is that when T crosses A and B, it creates four angles in the top, and it creates four angles in the bottom. And so we have different names for these types of angles. First of all, the area between the two lines, this is called the interior. So between the lines is your interior, and then outside the lines, which would be above and then below, that would be the exterior. So here's exterior, exterior. So on the side here, we can name some interior angles. Well, those would be the angles between line A and line B, so angle 3, angle 4, angle 5, angle 6. So angle 3, angle 4, angle 5, angle 6. Exterior angles, the angles that are outside the lines, would be angle 1 and 2, and then below would be angle 7 and angle 8. So angle 1, angle 2, angle 7, angle 8. Interior, exterior. All right, so now some pairs of angles. Alternate interior angles. To alternate is to switch. So we're going to be looking at interior angles that are on different sides of the transversal, which is T. One example would be angle 3 and angle 6. So angle 3, I'm going to use the logic symbol here. That's and. Angle 6. So if angle 3 and 6 are a pair of alternate interior angles, so are angle 4 and angle 5. Angle 4 and angle 5. So they're both interior, but then they switch sides of the transversal. Interior, but different sides of the transversal. Now you might ask, what about angle 3 and angle 4? Because they're on different sides of the transversal and they're interior. Well, because they get created by line T and line A, we've already looked at that relationship. That's a linear pair. They're going to be supplementary. They're going to add up to 180. So what we're doing is we're comparing one angle from the top with one angle at the bottom. So that's alternate interior. Alternate exterior is the same idea, except both angles are exterior angles. So angle 1 would be alternate exterior with angle 8. So angle 1 and angle 8, and then angle 2 and angle 7. Angle 2 and angle 7. Those are alternate exterior. They switch sides of the transversal and they're exterior. Again, we're not going to say angle 1 and angle 2 because we already know that's a linear pair. Corresponding angles. Corresponding is a word we're going to use quite often. It means same position. Same position. For example, angle 1, when I look at this group of 4 right here, angle 1 is in the top left position. If I come down to the 4 angles at the bottom, angle 5 is in the top left position. So one pair of corresponding angles would be angle 1 and angle 5. Another pair would be angle 2 and angle 6. Angle 2 and angle 6. They are both in the top right position. Angle 3 and angle 7. And then the last pair is angle 4 and angle 8. So bottom right, bottom right. So corresponding just means they're in the same place, the same position. The last one is called same side interior angles. You will also see this sometimes as consecutive interior angles. So they're both inside, but they're also on the same side of the transversal. So angle 3 and angle 5 are same side interior or consecutive interior. Angle 3 and angle 5. And then angle 4 and angle 6. Now, one of the things to notice here, that in this case, the two lines A and B are going to be parallel as well. All right, so this vocabulary, this can work anytime two lines cross. Anytime two lines cross. Anytime two lines are crossed by a transversal. But if you're talking about parallel lines, you're going to have some other things happen. First of all, if I say that A is parallel to B, then I'm going to label on my two lines, A and B, I'm going to put a triangle and shade that in. Now sometimes you might just see an arrow as well. If you see that symbol, that means that the two lines are parallel. The idea with parallel, we're going to define that up here. Parallel lines, pardon the sirens in the background here, the fire truck is running by. Parallel lines, those are two lines in the same plane, two lines in the same plane that never intersect. Two lines in the same plane that never intersect. So remember that lines will always go on infinitely, but if they don't intersect each other, if they're in the same plane, they're kind of traveling in the same path, in the same direction, so we call them parallel. So we label that by putting the triangle, the little symbols right here on the lines. The way we write this symbolically is we will say A, and then two vertical lines, B. A, two vertical lines, B. That means, the translation there, A is parallel to B. A is parallel to B. Now something interesting happens when you've got two parallel lines and the angle measures. Okay? For example, if you look at angle 1, when this line intersects line A and it creates angle 1, 2, 3, and 4. When this line intersects line B, it creates 5, 6, 7, and 8. But notice that because A and B are traveling in the same path, when line T intersects them, basically it's creating the same four angles. It's going to create the angles the same way, which means we're going to have angles that are congruent. Angle 1 and angle 5 are going to be congruent. Okay, you can almost eyeball this and say, okay, that's acute, that's acute. And it makes sense that with parallel lines, the transversal will create the angles in the same way. So if 1 and 5 are congruent, but you also know, remember vertical angles, when two lines cross, you know that the vertical angles are always congruent. So angle 1 and angle 4 are congruent, and angle 5 and angle 8 are congruent. So what happens is all four of these angles are going to be congruent. Using the same reasoning, angle 2 and angle 3 are congruent, vertical angles. But angle 2 and angle 6, they're in the same position. They're corresponding when they get created by the transversal. They're the same. And then angle 6 and angle 7 are vertical angles. So what happens is that 4 of the angles are congruent, and then the other 4 are going to be congruent. This is when you have parallel lines cut by a transversal. All right, now let's summarize this kind of individual situations. So we've got theorems here. Theorem, it's a rule that we can prove. If two parallel lines are cut by a transversal, then the alternate interior angles, I'm going to draw two lines cut by a transversal. Now to show that they're parallel, I'm going to label, that symbol there means parallel. The alternate interior angles would be like these two right here. Those two angles would be congruent. And one thing you might notice, if I trace that out, it kind of looks like a Z shape. Okay, coming back up to the original picture here, alternate interior would be like angle 3 and angle 6. Notice that we labeled those congruent, and then angle 4 and angle 5. So what happens is we'll have two pairs of congruent angles. We've got these two will be congruent, and then these two will be congruent. So it's like a backwards Z. This has a Z shape, but also the backwards Z, those are going to be congruent. Those are alternate interior angles. That's always true if the lines are parallel. When you have two parallel lines cut by a transversal and the alternating, excuse me, then also the alternating exterior angles. These two, notice that they kind of look obtuse. They are congruent. Those will be the same. And then this pair will also be the same. And notice when I label them, I use one arc for that pair, I use two arcs for that pair. They're not all the same. Okay, you have two pairs of congruent angles. So when two parallel lines are cut by a transversal, alternate interior angles are congruent, alternate exterior angles are congruent. Corresponding, now they're in the same position. Okay, there's my parallel symbol there. Corresponding would be like this position and this position. They're going to be congruent as well. So those two will be the same. Now actually we have four pairs of corresponding. I'm not going to label them all, but those two would be the same. We could also say these two would be the same. All right, that's corresponding angles. Corresponding angles congruent. And then the last group, the same side interior. So two parallel lines cut by a transversal. Same side interior would be like this angle and this angle. Now if you kind of eyeball this, this one looks obtuse, a little bit more than 90. This one looks acute, a little bit less than 90. These will not be the same. I'm going to label that one arc and two arcs. Now they're not the same, but if I come back to my picture up here, and I labeled that one arc and two arcs, but notice angle 5 and angle 6, that's also one arc and two arcs. See how they're next to each other and they form a straight line right here? That means they're supplementary, they add up to 180. So if angle 5 and angle 6 add up to 180, well, so do angle 4 and angle 6. So the relationship when you have same side interior angles is that these two angles will add up to 180. So I'll say that's angle 1 and angle 2. Angle 1 plus angle 2 equals 180. And we would say the same side interior angles, not congruent, they are supplementary, okay, S-U-P-P, sup. One thing you can look for with same side interior, you see the Z shape right there? Not the Z shape, the C shape. They form the letter C. So with parallel lines, the C will be supplementary. The Z will be congruent. So let's look at a couple examples here at the bottom. Number one, if A is parallel to B, find the measure of the missing angles. So they tell us that this is 67 degrees here. First of all, I know that vertical angles are always congruent. So this is 67. Now, if I want the other two angles, what I can do is I can look at, here's this angle here, and then here's the 67. But notice they're adjacent, they're next to each other, and they form that straight line. So they add up to 180. So if I take the 67 and I subtract it, take it out of the 180, what's left over is 113, which will be this angle measure. Vertical angles are congruent, so this is 113 as well. And if we go down to the bottom four angles, because the lines are parallel, they're going to be the same as the angles up here. So this will be 113, this will be 67, this will be 67, and this will be 113. Right? I'm going to stop the video right now. That's the end of part 1. So go to part 2 now and we'll finish this up.